Do this video on solving systems of equations by elimination. We will be talking about why does elimination method work when solving a system of equations, and by the end of this video you will be able to solve systems of equations using the elimination method. Solving by elimination, writing down our steps. So first step is we need to line up equations so the variables align. So in this instance, we have 2x plus 3y equals 12 and negative 2x plus 6y equals 6. We want to line those up, and then we can better identify which variable might be able to be eliminated. We line them up because we're going to add them kind of in an old school way. There's going to be three types of examples. Example one would be no equations need to be multiplied or manipulated. That's what this example is. Nothing needs to be manipulated here. An example where maybe one of the equations needs to be multiplied, and an example where both equations. We'll get into more depth with each one of these examples. Then we'll need to subtract or add to solve for the first variable. Don't worry about this example. I'm going to kind of go through it fast. You'll see an example in more depth in the slides to come. So we line these up. We look for what can be eliminated. The x's would be eliminated here. So if I kind of showed negative 2 minus 2, that's going to cancel out the x's. We can solve that for y, and we get y equals 2. And we need to plug, step 5, plug the answer in to get the second variable. So we're going to plug it back into the equation, and we can solve for x, and x would equal 3. And so if our answer was 3, 2, that is how we would write our final solution. Feel free to pause and catch up with the writing as necessary. Find the solution to the system using elimination. These equations have been lined up for you. If we add these together, this is a 1x plus 2, that's not going to eliminate. You have a positive 1 and a negative 1, that one will eliminate. So this is an equation. This is an example where no equations need to be multiplied. The y's are going to cancel if we just add them together. So we can start by doing that. Add these together, cancel out the y's. 1x plus 2x is 3x, 7 and 2 is 9. We'll divide by 3 on both sides, get x by itself. X equals 3. Now we need to plug x in to find the value of y. We can choose the top equation or the bottom equation. I'm choosing the top equation. Put the 3 in for x, and we got to move the 3 over, and we get y equals 4. Our solution here, as we would write it, would be 3, 4. We'll use our ordered pairs, parentheses, to write that out. Solve the system using elimination. Verify your answers algebraically using substitution. So again, we want to line these up and see if anything would eliminate. If we line these up, 1x and 2x would not eliminate. 3 and 2, that would not eliminate. So we have to do some multiplication to be able to get one of these to cancel out. If we multiply the top equation by a negative 2, that would leave us with a negative 2 on top and a positive 2 on the bottom. That's how we could cancel out the x's. There's a way to do the y's where we'd have to multiply both equations. This is a scenario where we can only have to multiply one equation. So if we multiply the top equation by negative 2, we have to multiply everything by negative 2. So this new equation becomes negative 2x minus 6y equals negative 14. We keep the bottom the same, and now you'll notice the x's are going to cancel. When we add the y's, we get negative 4y equals negative 8. Solve for y, we get y equals 2. And we're going to plug that y value back into one of the equations. I'm choosing the bottom equation this time. Plug the 2 in for y, and we get x equals 1. So our solution right at the moment is 1, 2. Let's verify it algebraically. So if we take the equation we didn't use yet, our x plus 3y equals 7, we can plug in the 1 for x, plug in the 2 for the y, and we can try to verify. 1. 3 times 2 is 6. 1 plus 6 equals 7. It checks out. Feel free to double check this one. Plug the 1 in for x, the 2 in for y. We get 2 plus 4 equals 6. Checks out. So our solution to this would be 1, 2. Solve the system using elimination. Verify your answers algebraically. Here's a scenario where both equations need to be multiplied. If we add the x's, not going to eliminate. The y's aren't going to eliminate either. So we need to make a decision. Am I going to eliminate the x's or am I going to eliminate the y's? In this case, I'm going to choose to eliminate the y's. Well, I can't multiply 3 by anything to get 7, but I can multiply 3 and 7 together, and that would be the same as 7 times 3. So I'm going to multiply the top by 7 and the bottom by 3. And when we distribute and do that, our top equation becomes 42x minus 21y equals negative 42. And our bottom equation becomes negative 15y plus 21y equals 123. And this is the key right here. Negative 21 and positive 21, those are going to eliminate. We can solve for x. We get x equals 3, and we're going to plug it back in to find the value of y. So we plug the x of equals 3 in for x, and we can solve this. We're going to move the 18 over. We get negative 3y equals negative 24. Divide by negative 3, and y equals 8. So our solution is 3, 8, but let's verify it. So if we take one of the original equations, notice I'm not taking one of the equations we multiplied. I'm taking this one inside the green parentheses, putting the 3 in for x, putting the 8 in for y, and it checks out. So 3, 8 is our solution. All of these you'll always be able to double check your solution algebraically. We have a word problem. You are shopping with a friend. You both buy clothes from the same store. You spend $120 on 3 pairs of jeans and 6 shirts. Your friend spent $110 on 4 pairs of jeans and 3 shirts. We're assuming that all the jeans cost the same amount and all the shirts cost the same amount. That might not be the case. You go to the mall, but for the sake of this problem, let's assume that fact is true. If we want to write a system of equations to represent the problem. Let's let x be the cost of jeans and y the cost of shirts. We spent $120 on 3 pairs of jeans and 6 shirts. So if we have 3 times our pairs of jeans, 6 times our shirts, we spent $120. The other friend, 4 pairs of jeans, 4x plus 3y equals 110. Find which variable to eliminate. If I multiply the bottom equation by negative 2, that will get me negative 6y, which would help us eliminate the y's. So then I only have to do one set of multiplication. So now the y's eliminate, leaving me negative 5x equals negative 100. Divide by negative 5, and x equals 20. Now let's plug that 20 back in, solve for y, and we get y equals 10. That tells us that each pair of jeans costs $20 and each shirt costs $10 each. We can verify it by plugging it into our top equation there. 4 times 20 plus 3 times 10 equals 110. It checks out.